Welcome, everyone. This is Wayne Eckerson, founder and principal consultant at Eckerson Group. And I'm here today with Kevin Poskitt, who's a product manager at SAP. And he's going to show us the predictive capabilities built into SAP Analytics Cloud. So, Kevin, it's all yours.
Perfect. Thanks, Wayne. So what we're really trying to do with machine learning in SAP Analytics Cloud is make it easier for people to get to answers and do their work as an analyst rather than spending time on creating content and actively being forced to build their own content. So the first place I want to start is showing you some natural language processing capabilities. So we really believe that people should be searching for answers the way they normally would, which is using natural language. So in this case, I have a data set loaded that's a profit and loss data set. And rather than the analyst having to build out charts, I could search and just sort of say, what is revenue, hit enter, and it will give me the answer directly. So it'll basically interpret my question and provide an answer. And I can extend this across any measure or dimension in my data set. So as I'm typing this, you can see that if I select region, it actually will show me that is in my data set. Now, I don't actually have to select this. It allows you to, so you can see what specific measures you have, but I could just delete this and quickly type in region. When I hit enter, since it knows that revenue is a key measure in my data set, it knows that region is a key dimension, it will automatically build out a chart for me. And if I like this, I can just hit add to story, and then this chart will be populated into my canvas. So the purpose behind this is to make it very simple for someone to quickly build out a large number of visualizations that may help them understand what's going on. The other thing that's nice is because we have planning and analytics and visualizations and BI capabilities on the same platform, we can actually do variance analysis. So this data set actually has both a planning model as well as the result set coming back. So I can actually type in actual versus forecast, and when I hit enter, it's going to automatically create for me this chart that shows the variance between my current actuals by region and the forecasted value. And I could add this to the story if I wanted to, and then it would actually show me the variance between the two as I select the different chart part. The other thing that's really nice about this is if there's a time dimension in your data set, if you ask to look at it over time, it automatically understands that there is a time dimension and will create a time series chart for you. If I wanted to, I could just look at this at the top level and add that to my story. So once I have a couple of these charts built out through the natural language search, or you could do it the traditional way where you're manually selecting the type of chart and the measures, I can also do a couple of additional things. So if I have a time series chart, anything that has time dimensions in my data set, I can actually click automatic forecast. And when I do this, it will build a time series forecast model for me and try to project out into future periods, essentially what would happen if historical trends in my data set continue. What does that mean future patterns are likely to look like? And I can, of course, change this slider and just look at, these are the future forecasted values. And then the shaded area that you're seeing is the upper and lower confidence bound of the model. So we're very confident within 95 out of 100 that it will fall within this upper and lower bound, with the dotted line being the actual projection. The next thing that you can do is within any data set, you can use a feature that we call Smart Insights. So when I select this, what happens is there's an algorithm running in the background that's analyzing the data in every individual chart that I choose to use this with. And then it will highlight for me little tidbits of information about what's driving the key measures inside of this. So in this case, revenue in June of 2015 was a significant contributor, 92% above average, and you can see the dotted line it creates for average. And it also tells me that the variation in revenue was driven significantly by a single product, in this case, socks. So it's designed to surface to the analyst some insights built by machine learning algorithms without an analyst actually having to go and build a model on their own. You can further dive into these details by selecting the light bulb icon, and it will then suggest some additional visualizations. So for example, socks, which we know is driving revenue significantly, is a top product, and it contributes 243% above average. And then we can see a nice little breakdown of our various product categories, as well as another average line. So you can see that both socks and tennis shoes are above average for this data set. It will also show me some other interesting facts. So in this case, it gives me a regional breakdown as well. And what I can do is I can add any of these objects to my story if I want to. So it's designed to make it easy for an analyst to continually explore through their data set and get unique insights that they can share with their business without them necessarily having to start from scratch or do everything manually on their own. The next thing that I want to show you is a feature we call Smart Discovery. So Smart Discovery takes this one step further, and it actually allows you to select within your data set any dimension or any measure and build machine learning algorithms that try to explain those for you. So from the splash screen, you would select Run a Smart Discovery. You'd want to select a data model that you have. So in this case, I'm going to look at some sales pipeline data. And then in this next screen, it will ask you, what is the measure or the dimensions that you're trying to explain? So in the case of a measure, what you can do is basically take any of the measures in your data set, like the number of customer meetings or how many licenses or contacts, or if you want to, you can also look at dimensions. Now, the difference between a measure and a dimension at a technical level when you're doing this is that a measure, you're going to build a regression. So it's going to find what are the key influencers driving that specific measure. And a measure that you probably are looking at would be revenue or expense. Within dimension, it's actually a classification, and it's saying, tell me the differences between two groups within a dimension. So for example, I could look at my customer segment, and then I can say, well, I want a baseline group, which is going to be my Fortune 500 companies, and I want to compare what the differences are between my Fortune 500 customers and then my small, medium business or enterprise customers. Once I've set this up, I can hit this run button down in the bottom right. And when I do that, what's happening in the background is we have an algorithm that's building a large number of various predictive models based on the data that is in the data set we provided. And it is automatically comparing all of the models it creates and trying to find the best model for this data set. So what it will eventually provide for you is a fully built out story showing you a comparison of the two groups that we selected based on a classification model that it has automatically created for you. You'll notice at no point did I have to actually specify classification or regression. I don't actually need to know what these mean. I simply need to select what I want to compare or what I want to explain, and this will actually build the model for you, so you don't need to have that sort of data science expertise, but it'll also build out a story for you to help explain what it's seeing based on the model it created. Now, as you notice, it is taking a little bit of time to do this, so I would just highlight that if you think about the amount of time it would take to go and have a predictive model created for you, have that data scored, brought back into your analytics system, and then build out a story around it, this actually really is a significant time saver, even if it does look like it takes a couple minutes to actually load on the screen. We're talking about minutes versus weeks in most cases in terms of how long it would take. So once this is finished building out, you'll get a number of different charts and visualizations. The first page is really just an overview that's going to show a summary of the different groups that we chose to explain. So in this case, as you can see, it's building out the overview of small, medium business and enterprise accounts versus the Fortune 500 accounts that we were looking at. And what it'll show me is the record frequency, so some heuristics about the data set itself. It'll show me the various historical trends over time, and I can change what measure I'm comparing these groups to. So every measure in your data set, we can compare. So in this case, why don't we actually look at the deal value itself? So when I select this, we're going to get new charts that show me what are the differences between Fortune 500 and enterprise customers based on deal value. So that's basically the total size of pipeline. And again, it takes a little time for all these to build out because there are a large number of data sets behind each of these models, but it does give you the ability to explore these in great detail. So I can actually see within Fortune 500, we have a very big concentration of large deals, so average between 120 and 180,000. Whereas with small, medium business and enterprise, which was my baseline group, the clusters are more in the 20 to 80K range. We can also look at how deal value has trended over time based on the Fortune 500 as one group and SMB and enterprise as the second group. And again, we have a time series forecast here that's highlighting that we're potentially going to see a decrease in the Fortune 500 deal values projected in the future based on historic trends. So there's a number of charts in here, and I won't go through them all, but the idea is that it provides the analyst with an overview and a comparison of these two groups based on the measure that you're looking at. And then we can also go into the second page, which is the key differentiators. The key differentiators looks at what are the driving factors between the differences in these two groups. So in this case, I'm looking at customer segment, but it could be any single category in my data set. It will tell me what number or what level of insight quality do I have out of 5. So in this case, it's saying 4 out of 5 based on historic sort of performance of the models as it was building them. And it will tell me what it thinks the key differentiators are. So in this case, deal value is a significant differentiator, as we saw in our data set. You know, there's basically a huge concentration of the Fortune 500 above 100K and almost nothing in terms of Fortune 500 below 100K. It also says the number of contacts that we have in those accounts and the types of customers, so existing customers versus net new customers. So just to highlight what this has done is it's basically allowed me to say, I want to compare two groups in my data set, and it builds an entire story explaining those differences based on machine learning algorithms. I could do the same thing if I wanted to explain a number in my data set. So what is driving pipeline or revenue in my data set? So that's the Smart Discovery feature, which is sort of the second along the path of adopting machine learning within an analytics context. And then the third is, what if I wanted to build a predictive model myself?
Hey,
so
Kevin,
with that, we have...
before
Sorry,
you
please go ahead.
I have one question.
Sure.
With Smart Insights, the first thing you showed, that was predicting what was driving one value, right? And Smart Discovery did the same, but in a much more in-depth way. So they're both doing causal analysis, right? But
yes.
Yeah, okay.
You can think of Smart Insights as a way to explain what are the causal relationships we can uncover in a single chart that I've created. And so it's basically, how do I find interesting facts in each visualization that I've built out and then drill in for more detail. With Smart Discovery, you're saying, what are the insights in my entire data set that I can uncover by building a classification or a regression model? Though we don't necessarily do it in those terms, in terms of what we ask the user to do. We just say, tell me what you want to explain. We build the model, and then we build an entire story around what you're trying to explain, as opposed to just investigating one specific visualization in your story. Does that make sense?
Absolutely. That makes perfect sense. Thanks.
Great. So this is sort of the final step in the journey, if you will, where as a business analyst, if you understand what a classification problem looks like or what a regression problem looks like, you can actually build a model on your own. So this is the new Smart Predict functionality. And in a nutshell, classifications are quite simple. If you think about something that is a yes or no question or a true-false statement, you're likely thinking about a classification problem. So is a customer likely to purchase? Is a machine part likely to break? Is a customer likely to leave my company? Those are examples of a classification, because the answer to that is yes or no, right? Or maybe what's the probability that something will happen? Whereas a regression, of course, is what is driving a numerical value like revenue? What are the key contributors and how much do they contribute? And then the third one you can build is the time series, which people pretty naturally understand, but it's if I'm looking at a value that changed over time, if those trends continue, what do they look like in future periods? So assuming as a business analyst, I know that I have a classification problem, the next step will be to create a predictive scenario. And then from here, I need to create predictive models within this scenario. The nice thing about this is you can think of the predictive scenario like a container under which you can build multiple models and compare them against each other until you find the model that you want to use, and then you can apply it to new data. So I'll create my first model. Of course, I can give it a name, and I will very creatively name it Model 1. The next thing that I need is my training data set. So if I'm building a predictive model, we have a training data set that gets used to actually build the model, and then what we call the apply data set, which is the data that I want to apply the model to in order to create the prediction. So in this case, I have a data set from a retail bank that has basically demographic details about customers, and then whether or not they opened a bank account in the past. And what I'm doing here is marketing wants to run a campaign to essentially determine whether or not someone is going to open a bank account, because we want to basically send some promotional action to try and increase the number of bank accounts that get opened. So what I'll highlight here is I've selected my data set. Now I need to select what's called the target variable. This is what I want to explain the behavior behind. So in this case, I want to explain whether or not or why someone has opened a bank account. At this point, I could just hit train predictive model. What happens automatically, just so that you can see behind the scenes, is when you load this data, it automatically encodes the variables and determines what type of variable it is and the storage type. So is it a string, integer, number, etc.? Is it a nominal, ordinal, continual type of variable, etc.? So it does this for you. You actually don't have to look at that screen unless you actually wanted to make changes to how it does the encoding. And all I really need to do is hit this button. So similar to before, what this is doing is it's building a large number of models in the background with every potential combination of variables in the data set. So using every variable, using only some variables, and then comparing those models together. And what it's trying to do is balance two very important capabilities or qualities about the model, and then it will provide you with statistical information to help you understand what the model that was finally selected is saying and if you should be using it or not. And so the two values that it's trying to balance is what we call predictive power on the left hand here, and that's the robustness of the model. It's saying how much of what you were trying to explain can be explained by the variables in the data set you gave me. So in this case, almost 70% of whether or not someone is going to open a bank account, this model can explain based on the variables that were inside the data set. The second value is prediction confidence, which is how confident are we that this model could be applied to new data and still hold true. So the left-hand predictive power is how explanatory is the model. Predictive confidence is how applicable is this model to new data. So in this case, we have a very, very high confidence, which is good, and a relatively high predictive power. Now, if I said that this is too low for me, what this indicates to me is I might need to go and search for other variables that we believe might explain whether or not people are opening bank accounts or not, right? So the more explanation that I have in my variables, the higher this is going to be. But for sake of argument, let's say I'm comfortable with this, but what I don't necessarily like is I have these external economic indicators. So for example, consumer price index and consumer confidence. This is basically telling me that macroeconomic trends seem to have a correlation to whether or not people are opening bank accounts. And that can be very interesting, but for the sake of argument, I could say I would like to see what would happen if I removed any exogenous or variables that I don't control, like macroeconomic trends. So what I'm going to do next is I'm going to use the exact same data set, and I'm going to build a second model based on this data set, but I'm going to exclude certain variables to see how that changes the model. So again, I've got my training data set. I'm going to be explaining why people open bank accounts, but I do have the level of control in the product to choose to exclude certain variables from the analysis. So in this case, I'm excluding anything that's an external economic indicator, and I'm going to train a second predictive model. And so this, again, is building every potential combination, but it's excluding those 4 variables that I selected. And then it's going to present me with the statistical information about the model that survived. And that's really the model that the system or the software feels is the best explanation that it's able to create with the data that you've provided. What's really nice here is once this is created, you will again get the predictive power and you get the predictive confidence. So we can see that confidence is still relatively high. Not surprisingly, the predictive power has gone down a little bit because we excluded some variables. And what I can do very quickly is actually compare my 2 models against each other. So I can see that the confidence is a little bit lower, the predictive robustness or predictive power is a little bit lower, but the number of variables in my model has gone up. So before, all of those external indicators were really strong drivers of whether or not someone was going to open an account. But by removing them, I can now see some of the underlying contributors that I have control over, like how long was their last contact duration, when did they last contact me, how many times did we reach out to them, what jobs or job titles do these people that I want to reach out to have. And what I can do is on any model, I can actually drill into the data pretty significantly. So I can look at every variable in my model. I can look at how much it contributes to the model, but I can also look into the bins itself. So when I'm building this model, the software automatically groups all of the values in each variable into specific bins, and it tries different combinations, and then ultimately the model that survives has these individual bins, and that gets done for you. So I could choose to say, I want to look at how much the inbound contact channel impacts my model. And it says there's a significant positive correlation with an agency visit, meaning if a person comes into the branch, we have a positive association with whether or not they open a bank account. If they call in, we actually have a negative association with whether or not they open a bank account. So not only can this model help me in terms of creating a probability score of whether or not John Smith is going to open a bank account, by looking at the reason codes underneath the model, it also helps shape the behavior of the campaign itself. So not only can we figure out who are the most likely to open bank accounts, we also know that if we build a marketing campaign, it should be built around trying to attract people into the branch where we have a higher probability of converting them than some kind of call-out campaign where we actually would have a negative impact. Now, let's say for sake of argument, I actually preferred my first model. It felt that it was more useful to me. It had higher predictive power and higher confidence. The next step would be to apply this model to a new data set. So I hit this little factory button here, and I select the new data set that I want to apply this to. Now I point out that this data set will look exactly the same as the data set that I trained it on, except that the value of whether or not they opened a bank account will be blank. And what we're going to do is we would basically create a new data set where we applied this model. And then what you can do is create a prediction probability, for example. So if I hit OK, this will apply this model to that new data set, and every single line will get a score, a percentage score out of 100. And that will tell me how likely a person is to actually open a bank account if I were to contact them based on the information I have about them. So what I have here in this screen is an example of once we've scored the new data, that then becomes a data set that I can use for a BI story. So in this case, I know based on applying my data set, here are all of the potential customers that in a marketing campaign we could reach out to. And then we applied a predictive model to that, and it automatically created for me 10 groups or 10 segments within that prospective customer base. And by applying the model, it will say, here are the people that are most likely to convert and be upsold and open a bank account. Here are the ones that are unlikely. And so the top group has the highest number of potential upsells. And as we move through the deciles, the number of expected upsells go down. Because of the functionality in Analytics Cloud, I could select one or any group in this visualization, and we'll automatically recalculate information about that group that we display below. So for example, in the number one target group, you can see how many customers there are. So there's 184 customers or prospects within this group. We think 91 of them are likely to convert if we approach them, and some demographic information. So marital status, education level, job type, etc. As well as what are their preferred contact channels. So they prefer to be reached out to by phone or by email. They would prefer the last contact channel was agency visit, which makes sense because we found that was very positively associated with whether or not someone would upsell. And the last contact period. So when did we last talk to these customers? So this just gives me a nice overview. The next thing that we can do is actually generate the contact list itself. So marketing says, provide for me a list of customers that I should go out to and proactively run a marketing campaign to try and get them in the branch and talk to them about opening a new savings account with this retail bank. And so what this will do is load for me the target groups that existed in my data set. And then when I select those, it actually has the contact's name as well as their contact information. So I could select, I only want to talk to target group 1, and then it will automatically filter those lists below, which I could export and basically send to marketing and say, these are the top 10% likely to respond. There's 184 customers. We think 91 of them will convert. Go run your campaign. The last thing that we can do, because we have this model, is we can actually do some campaign optimization. And this is some pretty neat functionality. So if we know who's the most likely to convert and the different groups within my data set, with some additional inputs, we can actually start to optimize my marketing campaign. So let's say I have a known budget of $17,000 and almost $500. I know it'll cost me $15 every time I'm trying to contact a customer. It's going to cost me $15 every time I try to email a customer. And if I have a customer open an account, let's say that's worth $200 to the bank. What this can do is calculate for me how many people, if I wanted to contact everyone, how much it would cost me, how many customers, how many people would likely convert, and what's my profit. And if we start talking about the hyper-segmentation, we say we know that the first group is the most likely to convert. What if we only contacted them? It will then say, well, you're contacting less people, so your campaign cost goes down. The number of customers goes down. The number of upsells increases. And so you get an increase in profitability by doing this. And I can actually keep selecting the various target groups, and it will recalculate and tell me when this campaign continues to be profitable compared to a completely randomized, let's contact everyone approach. And what I'll find here is once I hit the group number 5, that the profitability goes from, after the 5th group, the profitability goes from being positive to being negative. So I know that I need to contact just the first 5 groups, and that's how I'm going to maximize the return on my specific marketing campaign. Now, if I changed my budget or the cost per calling or emailing customer or the return per customer, this will actually recalculate everything and allow you to identify what is the optimal number of groups for you to contact. So this is just an example of what you can do with the Smart Predict functionality inside of Analytics Cloud. Of course, there's a large number of use cases, and our goal here is really to make the creation and consumption of predictive models democratized across business analysts so that multiple users have this capability. So Wayne, that's really what I wanted to show you today.
Great, Kevin. Very comprehensive. Data science for mere mortals. That's what I'm taking away from this. So very good. Thank you for your time.
Thank you.